Welcome to Brain Vision.
For this question, I will choose the following reference frame. I will choose my y-axis as pointing to the direction that is normal to the surface of the ramp, so this is my y-axis, and I will choose my x-axis to point upwards the ramp in this direction. I'm choosing the x-axis like that because the log is accelerating upwards the ramp. Then, my acceleration is positive if I choose my x-axis to be pointing upwards the ramp. Had I chosen my x-axis pointing to the opposite direction, I would have to include a minus sign on the acceleration that is given by the problem. So be warned about that. Now, to calculate the tension force, I should apply Newton's second law on the log using my x-axis because the tension force is parallel to this x-axis. Then, by using Newton's second law, we get the following. In the x direction, we have a net force component x, which is equals to the mass of the log times its acceleration. The net force in the x direction is composed by three forces: the tension force, the frictional force, and the x component of the weight force. Then, the net force in the x direction is written like tension force, which points to the positive x direction, minus the frictional force that points to the negative x direction, minus the weight force component x, which also points to the negative x direction. This is equals to the mass times the acceleration of the log on the x direction. So the tension force is equals to the mass of the log times its acceleration in the x direction plus the frictional force plus the weight force. And now remember that the frictional force in this situation, where the log is already moving, is the kinetic frictional force, which is given by the kinetic frictional coefficient times the normal force. So the tension is equals to the mass times the acceleration plus mu k times the normal force plus the weight force component x. And now we have to calculate the x component of the weight force. To do that, we have to take a look at this triangle here on the situation. So by extending the weight force, we get a 90 degrees angle here, and as a consequence, this angle must be a 60 degrees angle in order for the intern angles of this triangle to add up to 180 degrees. Now note that this angle between WY and the ramp is a 90-degree angle, meaning that this intern angle here is 30 degrees. Now we can use this 30-degree angle to determine what is the x component of the weight force. Note the following. The sine of 30 degrees in this situation, in this triangle, is given by the opposite side, which is wx, divided by the hypotenuse, which is w. Then wx is equals to w times the sine of 30 degrees. Then the tension force is the mass times the acceleration plus mu k times the normal force plus the weight force times the sine of 30 degrees. And the weight force, we know, is given by the mass of the log times the acceleration of gravity. Then the tension force is given by this expression. So now all you have to do is calculate what is the normal force. For that, we use Newton's second law on the y-axis. The net force on the y-axis is equals to the mass of the log times its acceleration in the y direction. And note that the log isn't moving on this direction or on this direction. Then its acceleration on the y direction is equals to 0. So the net force on the y direction is equals to 0. But the net force in that direction has two components, the normal force and the weight force component y. And it's written like normal force, which points to the positive y direction, minus weight force component y, which points to the negative y direction. And this is equals to 0. So the normal force is equals to the weight force component y. And for the weight force component y, we can return to this triangle, but now we use the cosine, because the y component is adjacent to the 30 degrees angle. The cosine of 30 degrees on that context is given by the adjacent side divided by the hypotenuse. Then the y component of the weight force is equal to the weight force times the cosine of 30 degrees. So the normal force is equal to the weight force times the cosine of 30 degrees. The normal force is then m times g times the cosine of 30 degrees. Now, let me clear the board so that we can finish solving this question. Okay, so we can exchange this normal force by this expression for the normal force. Then the tension is given by m times a plus mu k times m times g cosine of 30 plus m times g sine of 30. Now plugging in the values that were given by this problem, we get that the tension force is equal to 205 times 0.8 plus 0.9 times 205 times 9.8 times cosine of 30 plus 205 times 9.8 times the sine of 30. And this gives us a tension force of approximately 2,730 newtons.